All right, number 4. I have a target 125 meters away, the speed of the bullet, the muzzle velocity is 1895 meters per second, and knowing that distance equals velocity times time, I can figure out how long it takes. Okay, so they're asking, hey, how far down does it drop? If he's aiming right at the center, how far down will he actually hit this target? Which depends on gravity, right? Because he's firing it straight across, so the initial vertical velocity is 0, and it's going to have a certain vertical velocity over here because of the force of gravity pulling down on that bullet. How far down that is depends on how long gravity has to act on the bullet. So we're going to use this to find time, right? Because the only time that it has is the length of time it takes to get from here to here, going at this speed, which is obviously going to be a good deal less than 1 second if it's going this many meters per second, and it only has that fraction of that to go. So rearranging this, time is equal to distance divided by velocity, and we'll get something pretty small. Yep, 0.06596 seconds in the air. Alright. So notice how our range is connected to our horizontal, and that gives us the time. And now let's think about vertical. The initial vertical velocity, of course, is 0, since he's firing it straight across. The final vertical velocity is going to be the effect of acceleration due to gravity over this time. So times 0.06596, giving me a final velocity of 0.6464 meters per second, negative, or in the downward direction. Okay. Alright, so now we got to figure out the distance, alright, because this is its speed at that moment that it strikes the target. So, right, it is hitting it at a very slight angle. But it wasn't traveling that speed the entire time, so the distance below the center actually is going to be, right, the average. So my initial vertical velocity of 0 plus my final vertical velocity over 2 times that time. Which gives me 0.021. Let me think about significant digits here. 3. Yes, meters. Okay.